Okay, so these questions are all basically the same. Consider swinging a rock on the end of a string in large circles. Even though you're constantly pulling on the string, the rock never collides with your hand. Why is this? And the basic idea is because the rock is in constant motion. And then the Earth is attracted to the sun. What keeps the Earth from striking the sun? Constant motion and distance. Why does the moon strike the Earth? Constant motion and distance. And how could it be possible for electrons not to collapse into the nucleus? Again, they're pretty far away, actually really far away, relative to the size of an electron and the size of a nucleus, and they move fast. And the video showed pretty well that if you stop moving, it just keeps going in a line. And if you were to cut the line, and if you were to slow it down, it would fall right into the nucleus. Okay, this next page, recall that light is a wave. White light is composed of all the colors of light in the rainbow. All light travels at the same speed, 3 times 10 to the 8th meters per second. So speed is a constant. And we could say that for every 3 times 10 to the 8th meters, this time instead of doing it 1 second, we're going to call it a hertz, which is an inverse second. So meters times 1 over seconds, okay? Where the meters represents the wavelength, and hertz represents the number of waves that pass through a point in a second. What are the units for wavelength and frequency? Well, we just said this one is meters, and frequency is hertz. Okay, and then it says, the next question. Yeah. Our next question is, what are the units for wavelength? Oh, sketch a wave with a frequency of 2 hertz and a frequency of 4 hertz. Okay, so 2 hertz would mean that we have 2 wavelengths. And then 4 hertz would mean that we have 4 wavelengths. 1, 2, 3, 4. Okay, so if the frequency goes up, and that's what's happening here, this is going from 2 to 4. What happens to the wavelength? Well, if I were to, even if I don't measure anything, the distance from there to there versus the difference from here to here, frequency of light increases, the wavelength goes down. And I just explained it right up there. Okay, you need to put that in words. What kind of relationship is that? Well, as one goes up, if I say this is the frequency, and this is the wavelength, which is also represented by lambda, then we could say that this is an inverse relationship. So we'll approach a length of 0 as the frequency gets larger, but it'll never hit 0. We can't have a length that is less than 0 or even 0. Okay, and then question number 9 says, using a for every statement, what is the frequency of light that has a wavelength of 6 times 10 to the negative 8th meters? So I could say, remember from my for every statement, way back up here, I could say for every 3 times 10 to the 8th meters, there's 1 hertz. Okay, so go back to this. So again, oops. For every 3 times 10 to the 8th meters, there is 1 hertz. And we should say that, look, if this goes up by 6 times 10 to the negative 8th, or goes down by 6 times 10 to the negative 8th, how many hertz are there? Remembering that this is an inverse relationship. So I'm going to multiply this by 2 times 10 to the negative 16th. Okay, and then I'm going to divide this by 2 times 10 to the negative 16th. This will come out to be a half, or 0.5 times 10 to the 16th, which if I take that out, I'm going to have 5 times 10 to the 15th, because I'm going to take this, remember, and go all the way out 16 and come back 15. And then the last question, using a forever statement, what is the wavelength of light that has a frequency of 4 times 10 to the 14th hertz? Well, again, speed of light is a constant. For every 3 times 10 to the 8th meters, there is 1 hertz, 1 frequency. So they want to know the wavelength this time, which is this one, when the frequency is 4 times 10 to the 14th. Well, this went up by 4 times 10 to the 14th, which means this one will be divided by 4 times 10 to the 14th, because it is the inverse function, times, divide. 3 divided by 4 is 0.75 times, well, 10 to the 8th, and then we're dividing, so we're losing 14 zeros from our original, so this will be times 10 to the negative 6th. And then I always say, okay, let's put this in proper scientific notation. That means I'm going to come out 6, and I'm going to come back 7. So this is going to be 7.5 times 10 to the negative 7th meters.